Hello and welcome to another episode of Invalid Entry. I'm James Taylor, and today it was going to be something different, but I got some great feedback on yesterday's video. And Manuel, one of the guys I work with, he's an excellent front-end developer, excellent game developer in the past as well. And I'm not. I'm very much a server, back-end, data processing person. Anyway, he sent me some things that he would do in JavaScript development, JavaScript gaming, and I've copied those things into Python and taken some of his comments on board. I actually think there's an even better way of doing, and the reason I think it's better is because you wouldn't need to do it in JavaScript. It's to do with multi-threading in JavaScript and multi-threading in Python, and I will come back to that in a separate video because that is a nerd snipe. I was up all night thinking about it. He sent me some pseudocode, and I've implemented that. What you're seeing right now is not that. What we're seeing right now is the code from yesterday with all the background and everything removed. And I've also introduced two things. The first thing is it was like you should frame lock your rate of your speed of your program, not at the fastest you can run, but instead at the based on time. And I actually already was doing that with this thing called clock.tick. I was doing it ever since the very first version. I probably glossed over it quite quickly, but you can go check my GitHub commits and you can see that it's definitely in there on clock.tick 15. What this actually does is it actually remembers the last time you called clock.tick and then delays by the appropriate amount to hit that mark of 15 frames a second or whatever value you put in there. Which means that no matter what you do, this value here doesn't go over 15 frames a second. The second thing I've done is I've also just added in a font which takes ages to actually load the program now, and I'm just printing off the FPS. FPS is careful here. I'm going to be very careful to say it's the number of times it goes around the loop, the number of times I call clock.tick, not necessarily the number of times I call display.flip. However, because I call flip and tick, it is the same right now, but it might not be in the future. I will come back to that. And the second thing I print off is the raw time. Now Pygame clock has two functions, get raw time and get time. Get time tells you how many milliseconds was taken by the previous tick in completion, not the amount of time taken to actually do the rendering. So basically, raw time tells you how many milliseconds is taken per a cycle to get to this tick, which is why it's all over the place, even though the FPS is quite static. And I can prove that here by adding a little bit of a sleep in. Restart my program, and basically things happen in programming. Maybe you've got some network events, maybe you've got some user events, maybe you're trying to do something like load some assets and it just takes a bit longer to get that frame open. This load time here is by the font, the system font, and I should have used my own font rather than the system font, but yeah. So now you can see my raw time here is 20, but my FPS hasn't changed. Now what's interesting, if I bump that sleep even more, then you'll see the raw time go up beyond basically the minimum for the FPS, go up to about 60 or 70, and it will start going, yo, there's not enough time, and basically the FPS begins to drop at that point. This is where you start getting issues with the animation. So one of the things I did yesterday was I wanted the start animation to run slower than 15 frames a second. So he sent me this really good bit of pseudocode, which I'm now going to show you. So what I'm going to do is I'm just going to get rid of my star. I've actually got rid of everything else. Give it my star and bring in something called the generic sprite. Now my generic sprite isn't quite generic yet because I've had to hardcode the star. What I'm going to do is I'm going to take the sprite file name and the sprite so I can load it generically, but I'm also going to take the number of frames that I want to print and the speed. Now the speed I've put in here is actually the milliseconds between frames. Very important that in my version I'm taking the milliseconds between frames. Then all I'm doing is basically in my actual render function is passing in the time taken for the previous frame. So I know how long it is since I last rendered a frame. And all I'm doing here is working out how many frames would have passed, including fractions of a frame, since the previous render. And what that does is that gives me a number which is a float. So I just floor that so I get the actual frame, and the police are coming to arrest me. It's an ambulance, don't worry. I live in an ambulance station. It happens all the time. So what we now have, if I now run this with that saved and this generic sprite, is over here. I'm going to bring it in, and I'm bringing it in at 15 frames a second. I'm also just going to take my sleep out, which is down here, just so we have the same experiment as we had before, and we shouldn't see any difference to what we just had, apart from I forgot to take out my comment on my import. So import, run that as before, no difference, takes a bit of time to load, and there it is. Honest. I can promise you it's the font loading which takes this time. And it took a missing task. Sorry, I've got to actually, because I'm now passing time in. Pass time in there. I'm amazed at how slow. And if it's going to be this long, if I'm going to want that font loaded, I am going to put a splash screen on so I actually get to look at something other than a black screen. I will show you how to do splash screens in another episode. Because that's nice. That's actually less than the episode. That's a really boring thing. So now we say 15 frames a second, and my raw time is again up and down all over the place like normal. But my animation is working exactly as I hoped it would do. What we're going to do instead now is just demonstrate the features this has. So what this round, but the other thing he's doing, which is interesting, is he's using percentage sprites to actually round that down, to actually say if you've gone over 15 or whatever the number is, just round it down, loop back to 0, so it's clock arithmetic basically. What I can now do is I can now say I don't want to run at 15 frames a second, I want to run at 7 frames a second, and it will magically do the calculation again and say actually there's this many milliseconds between frames, therefore if that number of milliseconds hasn't passed, it will use the same frame as last time, rather than doing that. What I was doing was alternating. Now the important thing here is it actually works for any number, even if the number that you put in is what we call relatively prime to the number of frames you're actually targeting. You're targeting 15 frames a second. We actually want this animation to update at 7 frames a second. So occasionally you'll see it sort of stutter because it has 2 frames the same, and sometimes it won't. But it's in line with other animations on the page. That's what's really important here, is that if you were trying to time this up against other things going off, for example, explosions going off or camels running over pressure plates and that, all these animations would be generally in sync to within 1 or 2 frames. I'm going to quit that. And it works the other way as well. What happens if I want the animation to actually run faster than 15 frames a second? So I actually want to run at 20 frames a second. Well, at this point, I'm not going to actually run 20 frames a second. I'm still going to run 15 frames a second because that's what the main tick is on. So it's going to skip frames. Now, I don't know which frames it's going to skip, and it may actually be different frames on every time around the loop. But you can see there it is obviously faster, and it is still also running at 15 frames a second. So this works really nicely as well. Thank you very much for pointing this out to me. I also think we can go on better, and just to demonstrate what I do, I can now put my sleep back in. Say, even if we slow the processor down a little bit, you'll still get effect, and that's effectively what you're doing when you're saying I want more than 15 frames a second, or the animation to be faster between frames. I actually think in Pygame we can go better than this, but it might get a little bit complicated, and that's what led me awake all night, thinking actually I could run the number of ticks. The actual tick here, I could take this out and run that at max speed, but only if I decouple it from the display flip. So, and there's a reason I want to do that in Python, but not necessarily in other languages, and I'm going to come back to that after Christmas because it's quite interesting. It's all about input lag, and I got quite interested in it. That's it for me today. Thank you very much for the comment. I really appreciate it. It gave me a lot to think about. It wasn't the video I was planning on doing today. I was planning on doing a video on Koch snowflakes. Because we're going into Christmas, and therefore Christmas has to have snow. We actually have had snow here this year, which is really nice. Anyways, I will see you guys tomorrow. Until then, good night.